Hello learners. Today we'll be seeing about the project named Kidney Disease Prediction. This is nothing but a normal prediction kind of program where you will give some kind of values. Like let me just show you the data set. Here we have age, BP, and different kinds of medical values based on which there will be a prediction whether you have kidney disease or not. CKD means you have chronic kidney disease. Not CKD is something like you do not have this disease. You are normal. So our program will do something like it will calculate all the values. You will have to input all these details just like we do in computer tests, and based on those values, it will tell you whether you have kidney disease or not. So good with the introduction, and we'll now see how do we actually train a machine learning model and see the steps. So basically, the first step in machine learning model is to get the data. And after searching through the points, I got through data on Kaggle. So this is the name of the dataset, chronic kidney disease.csv, which we are getting through. And in any kind of project, we need to import all the libraries, which will be helpful for us to do our work. So here I'm importing all different libraries like pandas is used for data manipulation, numpy for number python operations, sklearn is the main library which is helpful to get the machine learning kind of algorithms, and cbon for graphical representation. Here I am loading my data set into the variable called data set. Now the second step, let's check out the second step, which is feature engineering or data. So let us check through it. What actually we are just seeing over here is that we see the shape of the data. 425 is nothing but like 400 rows and 25 columns in our data set. I have 25 columns uh, and 400 rows, which is quite good. Okay. So this is what I'm getting. Total number of data points is 400, attributes 25. Perfect. Now, when I go through my data set, I find some places where there are question marks. So how do I handle this kind of data set data? You can either remove these values or replace it with a mean value or something. Here, mean value of the particular column. But here I have replaced it with np.nan so that I can scale it to a particular kind of measure in the later stages. Now I divide our data set into two different classes. One would be where I have all the testing values or whichever values I'll give as inputs, and the last value will be of the whether I have chronic kidney disease or not. This is what it is. Like we are selecting the class column as our target value. And this is how we have divided our x and y coordinates. So target class is the class value and the feature set is all the columns from 0 to 24. Now what I'm doing is I'm using KNN imputer to ensure that all my missing values are transformed into a particular kind of case, and which I'll send to the feature classes so that computer can understand that. Similar case is with scaling, where I ensure that my values are between a particular range so that it is easy for the machine learning algorithm to understand the data. And encoding target class over here is nothing but I am changing my CKD and not CKD to zeros and ones. Because computer understands numerical things rather than strings or anything else. So what we do, instead of CKD, we replace it with 0 and 1 for no CKD. This is what encoding target class means, target encoder. So now I check out my data frame. This is nothing but ED, exploratory data analysis. Head represents the first 5 rows of your data set. This is what we get: age, BP, sugar level, and all the other stuffs. Okay. Now I describe my data set just to see through if there are any missing, what is the count, what the mean is, and how my data is distributed. Here you see the count 400, which means there are 400 rows and all. The mean of each of the columns, mean of RBC is 0.1117. The maximum value in RBC is 1. This is a basic introduction. Like when you want to get through the data set, what it contains, we use these kind of methods. Now, if I wanted to check out the information of my data set, whether they contain any non-null values, so it tells us that there are 391 non-null values, which means there are out of 400, 391 are non-null and 9 are null values. So I have to take care about them. I have to replace them or do some kind of operations, which we already did, right? Then after, as we check, when we move on from this kind of feature engineering stuff, we divide the data into training and testing set. Why do we divide the data into training and testing? Is that machine learning does not know what kind of data you are giving. First, you give machine the data and tell us that tell it to learn from the data based on certain parameters. This is how we get the result. Then machine learns it, and after it learns it, we have to check it, right, how well it is predicting or not. So we give it testing data, and depending on its result, we compare how it performed. Like the testing data got results as 1 to 10 in a particular row, and but the output was between 2 to 10, so it means there is some kind of variation. This helps us get to know our accuracy of the model, if the machine learned the data set well or not. So here we split the data set into a division of 70 is to 30. 70% data goes to the training set, 30% is for testing set. This is what we get. The size of trained data set 280 and the other one is 120 basic things. And now we actually visualize our data set as to how many number of kidney disease patients we have and the non-kidney disease. Zero represents kidney disease, around 240, I suppose, 245, and the other people are 150. So considerably good data set because we have a good distribution of values between them. Now, this is where we apply the KNN algorithm. This algorithm helps us get the regression values. We fit a line over here, not a line, but give based on some parameters, it calculates values and gives us the result. So here I import that model from sklearn, and I assign the KNN classifier object to KNN model. Then I give it some values because based on KNN means it calculates answers based on some n value. So what I do, I give it a range of between 1 to 10, and between this range, whichever model gives us the best accuracy, I'll consider it as the best parameter for us. So I give it a parameter grid where neighbors could be between 1 to 10. And what I do, keep I give it to the model. It trains itself based on these values called as train features and target features, which we divided over here. The train features and the target features. X and Y coordinates, it will learn based on them, and then I'll just print it out which parameters give me the best output. So when I see the result over here, it tells me that at n neighbors 2, I'm getting the best output. So this is what I get. At n equal to 2, I'm getting 97.5% accuracy, which is quite good. And this is the confusion matrix where 71 true positives and 46 true negatives, which is considerably good. And these two values, 1 and 2, are false positives and false negative, which should always be low. So good on this model. Now, what I do is like take another model called as decision tree. This again will fit the same parameters. Even this will fit itself based on train and target features, learn from the model, and again I'm passing some kind of parameters to it based on the number of leaves it has, 1, 2, 3, or 4, 5, to check at which leaf it learns the best. And similarly, we get the output over here. We train it and check the accuracy based on test features. We tell it to predict after the model has learned. We tell it to predict on some particular test features. The output we get is compared with the target we have. We already have some test values, testing data. We compare it with the predictions, whether the predictions are true or not. And here I am getting the prediction accuracy as 95.8, which was, I suppose, less than that of KNN, right? KNN had 97.5% accuracy, which means over here KNN outperformed decision trees. So another conclusion that there could be variations between models as well. Precision, recall, scores, and all. The best model over here was at leaf equal to 5. Okay. Again, we got a good amount of accuracy and precision. 95.8 is not bad. Let us check the confusion matrix. Yeah, here you see we have a bit uh, more number of false positives, I suppose. So, which means again that KNN perform better. Now, what I do, this was the end of like we had two algorithms with us, and now what I try to give some new data because that is what we actually wanted to with this model, right? Suppose I have these particular values for age, sugar level, BP level, what could be the output? Suppose I give B as the input for one. These are all the 24 columns which I gave as a particular input when we deploy the model. So what it does is like we pass the B to predict some values as to the function to predict what is the output based on B. And depending on this, it tells me that person actually has a kidney disease at inputs of B. Now let me try with AB and let us check the output. Over here, based on these parameters, the computer tells that great, the person is fine, he does not have a heart disease, kidney disease. So that's good, right? That is all because here we can actually this can what can be used in hospitals as well to get all the kind of inputs because they have all the inputs whatever they want like sugar and other values, and they can enter all these details into their code or any kind of GUI which you will apply, and based on that we can get the result whether there is kidney disease or not. Thank you.